Okay, in this first video, we're going to identify the limiting reactant. 4.5 moles of antimony are going to react with 5.5 moles of oxygen according to the balanced equation above. Which one is limiting? Well, what I need to do is pick a product. Fortunately, I have only one, and I'm going to see how much product each one of these reactants with these quantities is going to do. So let's start first with the antimony. So 4.5 moles of antimony, and here's where I need to actually use my mole ratio. I can see 4 moles of antimony is going to react with 1 mole of antimony oxide here. So I'm going to put that ratio 4 to 1. You'll notice that my moles of antimony above and below is going to cancel out, leaving me with just moles of antimony oxide. End result of this is going to be 1.125 moles of antimony oxide. This alone doesn't tell us anything. What we need to do now is compare it to the amount that we're going to get from 5.5 moles of oxygen. So I'm going to do the exact same thing here. Only difference being, in this case here, I'm going to use a different molar ratio. Here I see 3 moles of oxygen for every 1 mole of antimony oxide. So here I'm going to use that molar ratio of 1 to 3. Now when I do the math of this, I'm going to get 1.83 moles of antimony oxide. I looked at these two, I get less of this one, which means this is the one that's going to run out first. So my antimony is going to be my limiting reactant, whereas the oxygen is going to be the excess reactant. So just pick a product, in this case we have but one, and see how many of each we're going to get from either of my reactants. All right, in this case here, iron and oxygen is going to make iron oxide. Same thing here, I'm going to need to figure out what I need to do with each of these. So 6.7 moles, I'm going to use the 4 moles of iron for every 2 moles of iron oxide. I'm going to use that molar ratio there. That was obtained directly from the coefficients in front of my balanced equation. That's going to tell me the ratio between these. So now that I've gotten that there, I can cancel out moles of iron and I'm left with just moles of iron oxide. When I do the math, that's going to work out to be 3.35 moles of that. Let's compare that to what I'm going to get with oxygen, where I have 8.4 moles of it. So I'm going to use the ratio of 3 to 2 in this case here, cancel out my moles of oxygen, and what I'm going to be left with is just moles of iron oxide, and let's compare. This one, 5.6 moles of iron oxide. So looking at these two, the iron is the one that makes less, iron is the one that runs out first, so that would mean that the oxygen is going to be my excess reactant, whereas the iron is going to be my limiting reactant, just by looking at what they produce. Now I'm going to have phosphorus, and water is going to make phosphoric acid and hydrogen gas. Here I'm going to have it mixed because I have moles of one and grams of the other. We'll start with the easier one. I'm just going to do moles of phosphorus. I'm going to use the relationship of 1 mole of phosphorus is going to react with 10 moles of hydrogen. By the way, I could also do phosphoric acid and I would get the exact same results. I'm just going to put hydrogen here and I'm going to stick with that for all of my reactants. So I have 10 moles of hydrogen gas. As for the relationship between that and phosphorus, moles of phosphorus cancels out, and what I'm left with is 130 moles of hydrogen. Remember that 10 to 1 ratio was obtained from the coefficients from my balanced equation. Now, let's compare that to what I'm getting from water. Now, water is given in grams. I'm going to have to convert that into moles. I have 194 grams of water. I need to first convert that into moles using the gram molecular mass right there, whereas 18 grams is going to be 1 mole. Now that I have it in moles, now I can do the relationship of 16 moles of water for every 10 moles of hydrogen there. Once I've got that, all of these are going to cancel out, leaving me with only moles of hydrogen gas. That's going to work out to be, by the way, that 18 came from the molecular mass right there, and the 10 to 16 came from those coefficients. End result, 6.7 moles of hydrogen gas. Obviously way less. This means that my water is going to be my limiting reactant, and my phosphorus is going to be my excess reactant. I'm going to have a lot of that left over, but I run out of water. Bismuth nitrate and hydrogen sulfate is going to react to form bismuth sulfide and nitric acid. So this one here, I have grams of this and grams of that. So in both cases here, I'm going to have to do a little conversion. 17 grams, and I can use that molecular mass right there, 395. Now I've got it in moles. Now I need to use my coefficients. 2 of these for every 6 of those. When all is told, everything is going to cancel out except for moles of nitric acid, and I get 0.129 moles of nitric acid. So that's what I was able to obtain for the first one. Let's compare that to the second one now. Again, this one started in grams. I'm going to have to convert that into moles. 19 divided by 34.1 will give me that in moles. Then I use my molar ratio, or 3 moles of hydrogen sulfide is going to make 6 of this, sulfide, sorry. Cancels out, this is going to give me 1.11 moles of nitric acid. Looking at these two, it's obvious that the bismuth nitrate was the one that's going to run out first. That's my limiting reactant. Excess reactant is going to be my hydrogen sulfide. Way less of this one compared to that. All right, ammonia and oxygen are going to react to form nitrogen monoxide and water. So 0.07 moles and 0.11 grams. So this one's another mixed one. So I don't need to do any conversion on the moles. It's already there. I just need to use my molar ratio. That's going to work out to be 0.105 moles of water. Let's compare that to my 0.11 grams of oxygen. I need to first convert that into moles by dividing it by 32 grams. Then I use the molar ratio of 5 oxygen for every 6 water. Cancel everything out, and what I'm going to be left with in this case right here is going to be 0.004 moles of water. Obviously, this means that oxygen is going to be my limiting reagent and ammonia is going to be my excess reagent because I end up with a lot more water with that one.